Today we are going to see a topic in solid state physics. In one dimension close packing, there is just one way of arranging spheres. Here, the spheres are arranged in a row, touching one another. As a result, each sphere in contact with two neighboring spheres. Thus, in one dimension close packing, the coordination number is 2. Closed packing sphere in two dimension. This can be done in two ways. First is square close packing. In this type of packing, the second row of sphere is placed in contact with first row in such a way that the sphere in second row are placed exactly above the sphere of first row. In such an arrangement, the spheres are aligned horizontally and vertically such that each sphere is contact with four other spheres. So the coordination number is 4. If we call the first row as A type, the second row being exactly same as first row, so it is also called as A type. If we keep on placing such similar rows one above the other, then such arrangement is known as Aaa type or square packing. Hexagonal close packing. In this type of packing of spheres, the second row is placed in staggered manner such that the sphere fit in the depressions of first row. If we call the first row as A type, then as second row is different from first row, it can be called as B type. Now, if we place the third row above the second row in similar manner, we will observe that the second row of sphere are aligned with those of first layer, and each sphere is in contact with 6 other spheres. So the coordination number is 6. Similarly, on placing the fourth layer, we will observe fourth row of spheres are aligned with those of second layer. Hence, this type of arrangement is known as ABAB type or hexagonal close packing. If we compare square close packing with hexagonal close packing, we will observe that empty spaces are less in hexagonal close packing than compared to square close packing. Now, what are these empty spaces and what role they play in packing efficiency? The empty spaces in between the spheres are known as voids. These voids are responsible for decrease in packing efficiency of a solid crystal. More the number of voids, less of packing efficiency of a crystal. Now you must be wondering what is meant by packing efficiency. We have discussed about this in later part of the section. Now let us study about close packing in 3 dimension. 3 dimension close packing from 2 dimension square closed pack layers. This type of packing obtained by placing 2 dimension square closed pack layers above the first one, such that the spheres of the second layer are exactly above the spheres of the first layer. In this arrangement, the spheres of both the layers are perfectly aligned horizontally and vertically. On arranging layers one after the other in this pattern, we observe that each sphere is in contact with 6 other spheres, 4 from the same layer, 1 from the layer above, and 1 from the layer below. So coordination number is 6. If we call the first layer as A type, and since all the layers are also of the same type, this kind of arrangement is known as Aaa type of arrangement. On observing carefully, we will find this arrangement has generated simple cubic lattice, and its unit cell is primitive cubic unit cell. 3-dimension closed packing from 2-dimension hexagonal closed packing. The 3-dimension hexagonal closed pack structure can be obtained by placing 2-dimension hexagonal structure one above the other, that is, placing second layer over first layer. Let us take 2-dimension hexagonal closed packed layer A. Notice this layer has triangular voids. Place a similar closed packed layer in such a way that the spheres of second layer are placed in depressions of first layer. As the spheres of second layer are aligned differently as compared to first layer, so let us call this layer as B. On observing, we will notice that not all the triangular voids of the first layer are covered by the spheres of the second layer. This gives rise to the different arrangement and different voids. There are two types of voids. Tetrahedron voids denoted by T, octahedron voids denoted by O. Let us study how these voids are formed. When we place the closed packed layers above the depression of the first layer, we will notice at some places the triangular voids of first layer are being covered by the spheres of second layer. At such places, this type of void is called tetrahedral voids. Since tetrahedron is formed by joining the centers of four surrounding spheres, while at other places we will notice the triangular voids of first layer is coincide with the second layer, such that the triangular voids do not overlap. In such places, another type of void is formed, that is called as octahedron void O. This octahedron void is formed by joining the centers of 6 surrounding spheres. Now, in case we need to calculate the number of tetrahedral and octahedron voids in a crystal structure, then just knowing the number of spheres will serve that purpose. Suppose there are n spheres in a crystal structure, then the number of octahedral voids generated is equal to n. The number of tetrahedral voids generated is equal to 2n. Placing third layer over second layer. Stacking of third layer over second layer can be done in two ways. First, by covering tetrahedral voids. Second, by covering octahedral voids. By covering tetrahedral voids. The tetrahedral voids of second layer can be covered by placing spheres of third layer over them. On doing so, the spheres of third layer will get exactly aligned with the spheres of first layer. So, if we can call first layer A type and second layer B type, then third layer will also be A type. As the pattern of sphere is repeated alternatively in other layer, so the pattern is known as ABAB type, and structure formed is hexagonal closed packed HCP structure. In this type of structure, each sphere is contact with 12 other spheres, 4 from the same layer, 3 from the layer below and 3 from the layer above. So the coordination number is 12. By covering octahedral voids. In octahedral voids of second layer can be covered by placing spheres of third layer over them. On doing so, the spheres of third layer will not align with the spheres of first layer. So, if we call the first layer as A type, second layer as B type, then third layer will be C type. As this pattern of sphere is repeated alternative in other layers. That is, the fourth layer will be exactly aligned as the first layer. So, this pattern is known as ABC type. And structure formed is cubic closed packed or face center cubic structure FCC. In this type of structure, each sphere is contact with 12 other spheres, 6 from the same layer, 3 from the layer below and 3 from the layer above. So, the coordination number is 12. Thank you.